My dear students, I am very happy to see you today. Today, we will get the important lesson. Sure, we must say the important. Do you know why? Because it's our target to get a full mark. So, today, we will start for chemical analysis. This is about Unit 2. Are you ready to understand it? Sure. The lesson will be chemical analysis. Oh, what this word mean? Chemical analysis means we must define the relationship between each compound and its component. I don't understand. What this mean? I'll tell you now. How can you find that? Look. Human or time get a food. Do you know that? You ask yourself, what is the food? You learned it before. What this mean? You must sure it's iron. Iron, yes, the food, it means iron in your body. I want to know how can the iron found, how can make a reaction. This iron, as you see, has a different shape. It's vary from what to what, from the normal one to other one, positive and negative. Are you sure this can be? Sure, this can be this topic. My dear, positive and negative, it means ions. Now, what about this group? Look, my dear, for this. This ion start to move through this movie as you see. These particles can be combined together to make new compounds. Ask yourself, all time I ask, these compounds consists of what? You tell me it's a positive and negative. It means cations and anions. Yes, all of them, depending on cation and anion to obtain what? To obtain this compound, which tell me about chemical. Oh, chemical what? Chemical compound. So, I must make analysis. Now, what about to fly for this? Oh, chemical analysis can be divided into cations, anions. Do you know what it means? Positive and negative. Now, let's get all of them. As a beginning, you must say, play chemical analysis important role for many scientific researches. Yes, as what do you think? As a beginning, in medical field, chemical analysis can be obtained in medical field? Sure. How we can do that? Play important for scientific researches, for medical field, for diagnosis of some diseases. As what? The diseases here, diabetes, cholesterols, all of these, they are dangerous. But by chemical analysis, we can find the good result for the medicine. What helped me? The chemical analysis helped me for that. Not this only, but you must say in agriculture. Sure, improvement in the soil, properties of the chemical analysis to know the ratio between the element. Sure, without that, we can make any soil, any plant in any soil. It's difficult to do that because we have fixed ratio. Sure, what helped you for that? Tell me, chemical analysis. Also, we can say industrial field. Industry, sure, industrial field play important role for chemical analysis. Do you think how? This can be for ores. Ores, yes, we studied before for lesson 1. You remember the ores? It means it's a matter, it's an element with impurities. All of this, it means ores, and the product is used in all industry field to determine its identity for a standard specification. Sure, you must know a standard that. Also in environmental field. Environment has a chemical analysis. Sure, chemical analysis play important role for life. As a beginning, when I say identify and measuring harmful environment. Harmful, yes, because I want to be aware of diseases. How can aware? We can do that by knowing chemical analysis. Identify the measuring harmful environment. Also, we can say for this pollutants content in the water, in the food, everything around us. Also, percentage of the carbon monoxide. It's high, it's low, in between, normal ratio, all of that. You must know it by chemical analysis. Without that, you can't find good life. You must know sulfur dioxide. It's important pollutants in the environment. Not this only. We have nitrogen oxide gases in air. There are several examples that can't be counted. Sure, it's more and more and more that are based on chemical analysis that studies the chemical composition of substance to arrive your aim. So there is no good life without chemical analysis. My darling, what about the type of the chemical analysis? My dear, you must know now medical field, agricultural field, environment, everything in your life depend on what? Sure, depend on chemical analysis. Now, it has a one type or many types? Sure, it has a many types. But what we will study, let's see. For the beginning, you must say qualitative analysis. Qualitative. Yes, I know this word is very important, but the other, it means it involves the identification of the constituents of the substance. Oh, identification? Yes, every part. It means what? Whether in pure sample salt or mixture of the several substances. Do you know what this means? It means qualitative. But the other one we can say for this, it aims to estimate the percentage of each essential component of the substance. Estimating that? Yes. Percent? Yes. I want to know that. How can you know percent now? This percentage can be known by what? Can be known by qualitative chemical analysis. My darling, accordingly, practical qualitative chemical analysis should be done first to identify the component of the compound. Without component of the compound, you can't arrive to nothing. Why? In order to be able to choose. Choose what? Choose the appropriately quantitative method to analyze them to arrive my aim. This is the qualitative chemical analysis. Testing cations, aluminum. This about the example for qualitative chemical analysis. Now, my dear, when I get the solution, as you see, this solution of the salt of aluminum, Al positive 3, it means the cation. When I add drops of NaOH, we can see white precipitate is formed. I ask what this means. It means aluminum hydroxide. Oh, but when I add more of NaOH, there is nothing. Excess of NaOH disappear. What about zinc? We can see that, yes, this is the type of the cations. It means the type of the positive. Add a zinc, yes. Add a solution, yes. My question, what happened when I add the solution? White precipitate form by adding Good. NaOH, sodium hydroxide. Shake it many times. When you add more, exhaust, dissolve in NaOH. Where is the cation? Nothing. This is only no. I have also. Good. I have another cation. It means lead cation. It means BP positive 2. Add the same indicator. It means what indicator? Good. NaOH. What happened? Also, we have white precipitate. Add more and more and more for this cation salts. Shake it now. After shaking, concentrate for this. The color disappear. It means excess of NaOH means what? Means new formation of substance. I have a calcium. Calcium, yes, it's a cation, Ca positive 2. Now we add here new NaOH. Oh my God, would you see what happened? The color stay white, but here I add more and more and I try to shake it. Oh, where is the color? Dissolve? Yes, not dissolve. So cations are different. What about Cu, copper? Copper is a cation, sure. When I add the same reagent, it means what? NaOH, sodium hydroxide. Do you see the color? It's not white. Oh, it's blue. Yes, we know it's blue. NaOH, it changed this color to blue. It means you have new analysis. When I add more and more and shake it, nothing. The color stay blue, doesn't dissolve in NaOH. Iron, yes, we have iron too. When I get it, the other cation, add iron to test tube. This is my solution. When you add NaOH, do you think what happened here? We can say dirty green color is formed. Oh, greenish. You see, this is the color. Add more, shake it. Nothing. Dirty green stay as it is. Do you know why? Because especially cation. What about iron 3? The same? Let's see. When you add the salt solution of the iron 3 salts, add the same reagent NaOH. Now, you see the color here? Yeah, the color will be bloody red. Yes, red-brown. It means the color is changed from iron 2 to iron 3. Why? Because they are a different cation. Iron 2, green. Here, it means red. So, not dissolve in excess NaOH. Ammonium ion, sure. Ammonium ion, when I get ammonium ion, it means NH4, positive 1, salts, add some of NaOH. What's the color? No precipitate, no change, no color is it change. But I see you can find here ammonia gas. Ammonia, NH3. When I get a litmus paper and add, look at this, one red and the other blue. When you add excess of NaOH and I put this litmus paper inside them, heat the solution. Look and concentrate. NH4 salt here, by heating, it gives a gas. I want to know this gas is ammonia or not. I'm not sure. Concentrate and look for the red and the blue one. Look at this. When the color or the gas start to be evolved, the color of litmus paper, as you see, what happened? I see nothing. You see nothing? Yeah, but concentrate. Blue, stay blue. Red, stay red. What happened? The red litmus paper start to be blue. Oh, started to do that? Yeah, because ammonia gas is produced. Tested cation use aqueous ammonia. My dear, what about aluminium? I know it and we see it. ammonia and aluminium. Now, this is aluminium. When you get some of ammonia solution, ammonium solution here in H4, look, the color is changed. Yes, I'm sure the color is changed because it forms a new compound of aluminium hydroxide. Oh, doesn't dissolve? Yes, doesn't dissolve. Zinc with ammonium? Yes, with the ammonia solution. Look, when you add to the zinc, this is zinc solution, get the solution aqueous of the ammonia. The color is changed, yeah, the reaction as sodium hydroxide. But when you add more and more, the color disappear. It means good, it dissolved in ammonia solution as what? As aluminium, white, dissolve. Do you think has a reaction with lead? Let's see. Get at what this mean? This solution. Now, what is the other? Aqueous solution of the ammonia. The color is changed to what? To white. Add more and more for this solution in H4OH to give me ammonia gas. Shake it and shake it. What happened? Nothing. Doesn't dissolve. Calcium. Let's see. Calcium cation. Add this to the calcium. Now, add solution. This solution of ammonia, what happened now? I see nothing happen, but I think when you add more of it, the color is a change. Precipitate is a change. No, my dear, I see nothing. Copper. Copper too? Yes, can be. When you get the salt solution of the copper and add it to the test tube. Now, let's get the ammonia solution. When you get the ammonia solution and add drop after one, you can see the color blue. As what? As sodium hydroxide. Also, when you add more and more and more, the blue color stay as it is. Nothing happen. It means will be dark blue, but not dissolve. Deep blue. My dear, iron too. Yes, I think the same result as sodium hydroxide. Look at this. This is solution. Add sodium hydroxide. More and more and more. Now, look at the color. The same. Green, dirty green start to be formed. When you add more and more for this solution of reagent, you can find good. All of them stay dirty green color as you see. Good. Iron 3, I think the same result. Get a cation of the iron 3. Now, FeCl3 can be, why not? When you add more of the solution in H4OH, now the color is a change to good, red brown. As what? As we studied before for NaOH. Now, add more and more, the color become deep and the color doesn't change, but become what? Red brown BBT doesn't dissolve. What about the qualitative chemical analysis? This it means we mentioned that qualitative analysis aims to many things. To know the component of substance, whether it's a pure substance or mixture or several substances and so on. Also, it's a pure substance, then can be identified by their physical constants, such as what? We can know it by melting point, boiling point, molar mass, and so on. All of them about qualitative. My dear, reaction of sulfite ion with oxygen. How can you do that? My dear, as a beginning, when I get 2SO3 negative 2, do you know what this means? This is sulfide in aqueous. Now, we add Cr2O7 negative 2, the same aqueous. What is the result now? This only? No, I add what? H. H for what? H for this reaction to be more acidity. Do you think what happened now? You can see SO4 start to be formed. This by what? Chromium here can be formed. Yes, I know. Also water. Yes, I know. It's liquid. Two aqueous for the salts, chromium and water. My darling, you can deduce when you get a 5SO3 in aqueous solution and add 2, good, what this mean? Permanganate, MnO4. Do you think this aqueous? Yes, it's aqueous. And added to hydrogen. It means more acidity? Yes, 8 molecules of what? Of H. Now, do you think what is the result now? The result 5SO4 positive 2 aqueous. Also, you can obtain 2 Mn positive 2 also in aqueous. What happened? You have a water which work in the liquid. My dear, what else? SO3, we know it's a sulfide, positive 2 aqueous. Added to what now? 2Br2 in its aqueous solution. It means bromide. What happened when they add it to each other? It will add to H2O water. You can find the result as SO4 group of sulfate in its aqueous solution. Negative 2 is formed. Also, you can find 2Br negative 1. So, the component can be known by knowing the quantitative chemical analysis. My darling, the result will be more in the form of the ion. This is the chemical analysis. It means get its component. Consists of what? Small parts. Of what? Cation and anion. To obtain this solution for its aqueous. What about to catch a precipitation method? This method based on precipitation of analytic. Precipitation? Yes, we can say that. Look, my dear, it's form pure, springly soluble compound with a constant and known chemical structure. Springly soluble, yes, and make precipitate, yes. So this is precipitation, precipitation analytic. My dear, what about to catch this? This filter paper with precipitate is transferred to what? Ignition corpuscle, and in the same completely ignited until volatilization of the constituents of the filter. تاني. Completely ignited until volatilization of the constituents of the filter paper. Good and important. My dear, the mass of precipitated remains, which is found in the back of the tube. At the end of the tube, we have a remains. This remains after ignition is weighted what? And used, weighted and used for determine the mass of analyte. Mass of analyte can be obtained by what? By this precipitation substance. It's important, easy. My dear, what about to get example? We need this example to tell me what happened for here. When I say to you, sodium sulfate solution was added to a solution of barium chloride. Yes, I know that. Now, the complete precipitation of barium sulfate. Barium sulfate, complete precipitation? Yes, I'm sure. Now, my dear, the mass of isolated precipitation after filtration and the drying was found. How many grams? 2 grams. What else? You can say, calculate the mass of barium chloride in the solution. You must know the atomic mass for the oxygen 16, sulfur 32, chlorine 35.5, barium 137. Now, this number, yeah, this precipitation, I'm sure. What about to start to answer? Write the balanced chemical equation and calculate the molecular mass. Equation should be written in the right form, in balanced form. What about to fly to this? Catch it now. The substance in this relation, in this case, there are barium chloride and what else? Barium sulfate. I am sure. Barium chloride, barium sulfate. Now, solution. As a beginning, you must say X mass of barium chloride. I don't know it. We say X mass because I don't know what its mass. Number 2, I can say equal 208 by 2. Do you know from where? Yes, this is the mass number of barium chloride, BaCl2, to give me this result. Now, add it over 233. What this else? This also the mass number for the product. My dear, the answer 1.785 grams. It's good to say that, but this for what? For X mass of barium chloride. Catch it now. 208 grams, 208 grams. Here, give me what for the product? 233 grams. The first barium chloride, you see? Now, X grams, give me what? Give me 2 grams, which given in the problem, you remember? So, calculate the mass number for each one as you see. Molar mass, X equal to gram. What about to make cross multiplication? When I make cross multiplication, I find that BaCl2, I know it, plus what? Na2SO4. Arrow give me what? BaSO4 plus what? Plus 2NaCl. When I look at all of this equation, you be sure you will use only BaCl2 and BaSO4. We arrived to the end of the lesson. Do you think you understand it? I think so. Study it well to get a full mark. I'm waiting you to tell me your opinion about the lesson. My dear, see you soon. Thank you and goodbye.